Hello, we are the LICOR-710 dashboard team. We are project 26079. Yuma produces crops on 180,000 acres of active farmland. However, reduced rainfall and increased demand on the Colorado River are limiting irrigation water. Irrigation decisions depend on accurate and timely environmental data, yet raw sensor data alone can be difficult to interpret quickly. Users need a clearer way to monitor field conditions and trends. This project is intended to support the University of Arizona Agricultural Extension, as well as farmers and agricultural decision makers. The evapotranspiration data is cleaned and put into a database first, then into a dashboard that displays data in a readable format. Our long-term goal is to provide more information for decision makers if a water crisis were ever to occur. The reason the dashboard matters is because raw sensor data alone is not easy for users to interpret information quickly. The dashboard provides real-time conditions, historical trends, and system status all in one place. It supports better irrigation and water management decisions, and without a dashboard, important sensor data would be harder to access, monitor, and act on.
The LICOR-710 evapotranspiration sensor measures the total transport of water from evaporation and transpiration over an area. The output from the LICOR-710 is evapotranspiration, energy flux, and other parameters in 30-minute increments. The LICOR-710, when paired with an IoE module, is a water node on LICOR Cloud. How LICOR Cloud provides data. The IoE module powers sensors for continuous long-term operation while simultaneously posting data to the LICOR Cloud via a cellular network. It allows operators to view data and assess results from sensors remotely. How the backend processes data. The backend takes the raw data and cleans it, such as it removes noise and errors, applies calibration and corrections, converts it into meaningful metrics, for example about transpiration rates, aggregates data in hourly and daily averages, triggers alerts and thresholds. The processed data is stored in Microsoft Azure, in databases, storage accounts, and etc. Microsoft Azure provides scalability, such as it handles large datasets, reliability, such as backups and uptime, APIs for accessing the data. It keeps everything safe and accessible. How the dashboard shows the data to users. Some of the data the dashboard displays are graphs such as live ET chart and historical ET chart, real-time sensor readings, and alerts for thresholds.
This slide shows our dashboard prototype and features. As you can see on the dashboard image, it gives users a live view of evapotranspiration data, historical trend charts, data quality indicators, and sensor details in one place. It also supports export options and provides alerts, which helps turn raw sensor readings into information that farmers and researchers can actually use.
The Live ET feature displays the most recent evapotranspiration readings as new sensor data becomes available. It allows users to monitor current field conditions and view recent ET changes over time. The historical ET average feature shows average evapotranspiration values over past days to help users identify typical trends. The historical total feature displays accumulated evapotranspiration over time to support broader irrigation analysis. Together, these features help users compare current conditions with past patterns and make more informed decisions. Threshold alerts notify users when evapotranspiration or environmental values rise above or fall below expected limits. They help users quickly identify abnormal conditions such as low soil moisture, high temperature, or unusual ET changes. System alerts also indicate issues such as stale data or sensor disconnection that may affect dashboard reliability. Together, these alerts improve situational awareness and support faster response to changing field or system conditions. The interactive map displays sensor locations and field placement information to help users visualize where data is coming from. The timestamp and sync status panels show when the dashboard was last updated and whether the system is currently synchronized. The soil moisture and temperature panel gives users additional environmental context beyond evapotranspiration data. The missing packet and sensor uptime indicators help users monitor data quality, system health, and reliability. The comments feature allows users to add notes and observations for collaboration and record keeping.
On this slide, we focus on testing and overall progress. We verified the main features of the system and tested things like exporting data, secure login, and ET thread accuracy. We also check real-time updates, stale data behavior, and how the system handles missing or corrupted data. On top of that, we made sure everything runs reliable using Azure. Right now, the system is stable and ready for demonstration. One of the main challenges we faced was integrating and syncing data across systems, but we were able to overcome that. Overall, we turned raw data sensor data into clear and useful insights that can support better decision making. To conclude, our team developed a real-time cloud-based dashboard for LICOR-710 sensor data. We focus on turning complex environmental data into something clear and easy to use. These systems help support better irrigation decisions and water management by combining sensors, cloud technology, and data analytics into one platform. Looking forward, it also has the potential to expand into predictive analytics for crop health and sustainability. Overall, this project shows how engineering can be used to solve real-world environmental challenges.
We are the LICOR-710 dashboard team, Team 26079. My name is Robert J. Monson. I am the dashboard team leader and a front-end developer.
Hi, I'm Daniel Edith Lopez Hernandez, and I'm part of the dashboard team and software development team, as well as UML designs.
Hi, my name is Alberto Lopez and I am the head coder and the backend developer.
Hi, I'm Jennifer Barajas. I'm the quality assurance engineer, tester, and debugger.
My name is Charlene Molina and I am the full stacker for the project.